We continue in the review section for section 1 by talking about some more key ideas. Of course, everything in the review section in the review chapter is a key idea because it's fundamental that you understand this to go on and tackle some of the new topics that are coming up here in chapter 1. But we're going to look quickly at the order of operations, something you've had back since grade school. I went ahead and wrote down PEMDAS, although I'm not a big fan of writing that out because it has a tendency to kind of make students believe that multiplication comes before division and addition comes before subtraction. It's all based on order. But I have a pretty complicated looking example here that I'm going to run through. I do want you to note, I'm going to write down every single step, and you could probably combine a few of these steps. Don't forget your equal signs, that one line equals the next. So we do the stuff in the parentheses. We have 1, 2, 3 sets of symbols of grouping. We'll do the innermost set and work our way out. First the parentheses, then the brackets, then the braces. So in the parentheses I have -1 minus 3, which of course is -1 plus -3. And that is -4. So this is going to be plus 3 times -4 raised to the second power. -4, I kept in parentheses because I don't want you to multiply yet until we do the exponent. We do exponents before multiplication. So again, equals 50 minus the set of 2 minus the set of the square root of 121 plus 3 times -4 times -4, you're squaring it, is a positive 16. And now we're ready to simplify the expression that are in the brackets. Equals, now this expression, I know what this is equal to. I'm going to save them for just a second. I'm going to go ahead and multiply next before I try to add. You could go ahead and state that the square root of 121 is 11, but I don't want to ruin it. So I'm going to write this as the square root of 121 plus 48. And now I'm going to add those, so I will take the square root of 121, which is 11. Now, I'm going to do the stuff inside the brackets next. 59. I drop the brackets, minus, careful now with your signs. And of course, now I'm going to do the subtraction that's inside the braces here. 2 minus 59, same as 2 plus -59. So this is going to be 50 minus, this is going to be a -57. And of course that's 50 plus a positive 57, or 107. I don't think I made any silly arithmetic errors, and again, you would probably combine several of those steps. I wouldn't suggest when it's kind of complicated that you combine too many of them and make silly mistakes, but by now you're able to do a lot of this arithmetic in your head. I went ahead and put down every step. I did want to also make the huge statement here. I don't know if it's huge, I just said they're huge. It's where we are talking about division by 0. You cannot divide by 0. I went ahead and just put any real number 3 divided by 0. That's undefined. The reason, of course, is that if 0 goes into 3, it has to go in however many times, so that this times 0 is going to give me 3. Well, that's not going to happen. Anything times 0 is 0. So this is undefined. Now, if you have 0 divided by 0, we don't state that it's 0, we don't state that it's undefined. We actually use the expression indeterminate. And you won't see that, and most likely you won't see that, at least with any consistency, until calculus. I'm going to go ahead and jump to algebraic expressions. Now, I didn't really define a term, but we know that terms are those expressions that are being added or subtracted. It says it's a single term or the sum of 2 or more terms. And I have this expression right here. I have 1, 2, 3, 4 terms here. I have terms are separated by plus signs and minus signs. Remember subtraction, because it says sum. Subtraction is the same as adding the opposite, so this is the same as plus -3, if I wanted to put it in that way. But I have 4 terms here. Let me go ahead and underline them. I have this term here, I have this term here, I have this term here, I have this term here. Now in this the last term there, you're dividing by the variable y. what we would normally think of as dividing by the variable y, we may remember from our algebra days, this is the same as y to the negative 1 power. You can see this term, and this term all contain variables. But only this term here, the negative 3, is a constant term. It cannot change. There is no value that would make negative 3 not equal to negative 3. The coefficients go with the terms with the variables. So this one is not a coefficient. A lot of people think it is. My coefficients are the number factor, the real number factor that's times the variable. So negative 5, positive 5, and negative 2 would be my coefficients there. I'm jumping again right into the properties. I've listed the first names of the properties. There are 2 commutative properties, 2 associative properties, 2 identity properties, 2 inverse properties, and of course good old Mr. Distributive Property at the end. The commutative property is for adding and for subtracting. Addition, of course, means that if you add 2 numbers, 2 real numbers, it doesn't matter which order, CO commutative, CO change order. This is for addition and for multiplication. The associative property has to do when you're adding or multiplying 3 terms. We're not going to change the order, but we are going to change which ones we add first. Because without any parentheses, we would add from left to right. But I'm going to say that this expression, where I add these 2 terms first, is equal to the expression if I add the first 2 first and then to the C. And that is also going to work for multiplication. I did not give myself very much room, so I'm going to sneak the multiplication up here and write this as A times the quantity B times C is equal to the quantity A times B, all that times C. So again, commutative for addition, commutative for multiplication, associative for addition, associative for multiplication, identity. I think of identical. Identical means that for addition, when we add 0 to any number, we just get that number right back. A plus 0 is equal to 0 plus A is equal to A. Well, for multiplication, we know that A times 1 is equal to 1 times A is equal to A. We get the number right back, whatever the real number A is. Identity, identically right back. This is the additive identity, and this is the multiplicative identities. The inverses have to do where we combine terms or multiply factors together that gives us the identity. So what would we add that would give us 0? Well, we would add opposites. And it doesn't matter what order. Again, I didn't give myself very much space. Sorry about that. And I would get 0. Or we would multiply reciprocals, where A can't be equal to 0, and we would get the multiplicative identity. The distributive property is one that's used a lot, especially when we're combining like terms, which is coming up here in just a bit. To distribute, we have a factor over a sum. And we multiply that factor times each term of the sum. So A times the B, and add to that A times the C. Distributing over. A lot of people like to draw the little arcs like that. Well, we're almost done with this. Let's just finish this up in just a second. Okay, the distributive property is probably the most used of the properties that I mentioned before in algebra. I went ahead and restated it, and I went ahead and reversed the sides around because we use the distributive property. We don't even think about it when we do it now, but we use the distributive property when we're combining like terms. 3x plus 5x. I mean, we know why now that that's 8x, but the reason that it's 8x is because they have the common factor here of x, and we distribute, we factor that out. Now I went ahead and put the x on the right-hand side because traditionally it's used on the right-hand side, and we would distribute this way as well, or we could flip the around using the commutative property and then distribute more traditionally. But we can add now the coefficients of 3 and 5, and we get 8x. And we can use that to simplify expressions like the one here below. Now, this is a little more complicated, and we're going to have to distribute a couple of times. I'm going to grab a different color pen here. I'm going to use the blue pen because I can see I'm going to have to distribute here, and I'm going to have to distribute here. Now, I have to be extra careful here because of the subtraction sign. Because that subtraction sign, I'm thinking of that like a -3 here. So I have 12. A -3 times 5x is a negative or minus 15x. A -3 times minus 2y Negative times negative is a positive or plus 6y. Parentheses are gone. Over here, distributing, it's a plus sign in front of the 5, so it's like a positive 5. Times 3 is plus 15. Positive 5 times a minus x, positive times negative, negative or minus 5x. And I don't multiply the 5 times the y is not in the parentheses, and now I'm looking to combine like terms. I am not going to use the distributive property and as I'm writing it out. I am going to use the distributive property kind of in my head and look for like terms. Now terms, again, are those expressions that are added and subtracted. Like terms have the same variable and the same exponents for the variable. They differ only with the numerical coefficient. Or they could be exactly the same. So I have like terms here. Those are my x's. I have like terms here. And then I have my constant terms. Constant terms are always like terms. So I like to go alphabetically. I like to do my variables and then my constants on the end. Minus 15x and a minus 5x. It's like a negative 15 and a negative 5. That's negative 20x. Cross them out so I don't get confused with them. And then I combine my y's. I have a plus 6y. I have a minus 1y. That's a plus 5y. And then I can combine my constant terms. A positive 12 and a plus 15 is a plus 27. That's as far as this guy goes. It doesn't combine. These are not like terms. And that's as far as I can go. Notice I use the distributive property here to eliminate the parentheses. And I also use the distributive property, although I didn't write it out, when I combine like terms. This particular section finishes with just a little information about something that we're going to spend a lot of time on, and that's the idea of mathematical modeling or algebraic modeling. It's story problems, word problems. So the key, of course, is to make sure that you can translate the written word into arithmetic and algebraic symbols. So I've listed some examples. These are not, this is an incomplete list. This is just some of the ones like equals and is and will be and something cost. This refers to equality. When you see that in a story problem, and I have one example coming up here in just a second, we know that this represents equality. You'll see is most of the time. Times of, when I say like half of a number, twice, product, those all refer to multiplication. Okay. There are others. This is just some of the more common ones. Divided by, per, each, quotient. That quotient should give it away. This is division. Minus, less than, difference, decreased by. That sounds like subtraction to me. Now I do want to make note of this guy. Less than, when it says 5 less than a number, it does not mean 5 minus the number. It means you're subtracting the 5. The less than kind of reverses the order around. Put a little star next to that guy. That's the one that's caused lots of problems over the years. Now here, more than, plus, sum, combined sums, your tip off, if nothing else, or plus, that we are adding. Now more than also traditionally changes the order around, but with addition, since it's commutative, it doesn't matter if you write 3 plus 5 or 5 plus 3. If I say 3 more than 5, I would want to write 5 plus 3, but 3 plus 5 will cover it as well. Now, I kind of grouped some here. These ones have to do with inequalities that involve greater than. This is greater than, this is at least, which would be greater than or equal to. These ones over here, more inequalities, but less than. Is less than, right? Is at most means is less than or equal to. And then the bottom one here, just a couple of examples of our variable. Well, we'll use an n or an x or a y or whatever you choose to use. A number, how much, that's our unknown, that's our variable. And we have an example below. It says the sell price S of a lawnmower is the difference, we know what difference means, back up here, is the difference of the original price and the amount of the discount, which makes sense. You get the discount, you take it off the original price. So we know, it says write a model to represent the sell price. I didn't leave much space there, so I'll just kind of shoot it over here, that the sell price is equal to the difference of the original price P and the amount of the discount D. And that would represent the sell price there. That's a really basic idea, but this is just an introduction. And we're going to hit it hard here in this chapter on review. So if you have any concerns, if you Need to go back and watch the video again? By all means do before you go on to any of the assignments.